Okay. I see the data. I see the stream. Looks like everything's good. Nothing dropped. I see audio. And this time I actually have audio monitoring. So I can hear myself through the mic here. Hey. Well, looks like we're live. Hello, everybody. This is meteorologist Andrew Pinero. So I'm using the shotgun mic on the side right now just because we're going to do some VRing. Because there was a major scientific discovery today. A black hole. There's actually never been any full evidence of this before. Like physical evidence. It's always been theorized. There's always been, just based on the movement of stars, we think a black hole. But now there was a photo, and that was the thumbnail. The thumbnail I have is right from NASA, and the NASA website had the picture right up there. So we're going to go into the VR machine. I'm getting a whole bunch of notifications right now. Yeah. So we're going to go into the VR machine, that Universe Sandbox, and we're going to play with the solar system and some black holes. And we'll see if we can mimic that. I don't think Universe Sandbox can make it look exactly the same, which is similar to the Interstellar. If you've ever seen the movie Interstellar with Matthew McConaughey, that was a very accurate depiction of what the black hole would look like. And we're going to go into some of the anatomy of a black hole as well. But first, we're going to talk about some weather. And I am going to share this out with everybody. I see a couple people watching. Thank you for joining. How was your day, guys? I don't want to stop the stream. Where's the share button? There we go. I'm going to share this out. We got the Twitters. We saw a black hole today. Lots of hashtags. Science. Astronomy. Physics. Space. The final frontier. Okay. Got that tweeted out. Now to Facebook. Oh, knock on wood. I don't want to jinx it. Everything seems to be flowing very well tonight. All right, that is posted there. And I posted this actually earlier on my Facebook page. This is truly incredible. The first ever image of a black hole. It's not actually visible light. I think it's X-ray. But still, it's an image. I think the microphone does a pretty good job blocking this out, but there's a little bird tweeting outside. Okay, that looks all posted. Stream health is good. It always starts out bad for some reason with YouTube, but I'm watching 0 drop frames whatsoever right now, which is good. Alright, so we're going to start, before we get into the black hole stuff, we're going to start with some weather. This is games and storms. Or storms and games. I like games and storms better. Okay, let me get some things up here. And we are going to look at the blizzard, too, that's going on. So I got the radar. Let me pop up some satellite. There we go. We got the satellite. Pop up some of the models. Alright, and I do just want to see if I can get that picture from Interstellar. Something not copyrighted. There's one from The Verge, and we know how The Verge is. Let me see. Anything copyright free. Which is usually wikis or .gov. It looks like we'll just stick to what we have. Huh. Of course, you have the phone booth flying through space. If anyone gets that reference, let me know in the comments. Okay. So we're going to start with the radar. And that should be set. I think it was this button. Yes. Good. All right. So we're taking a look at the radar right now. And there's really nothing happening at all in the northeast. It looks really nice. And it's going to be like that just for a little longer. For tomorrow, it looks to be good. Except later on into the afternoon, or more so the evening, we'll be seeing some increasing clouds. But overall, not that bad of a day. I know today was a beautiful day. I actually washed my car. I didn't film it just because we've seen time lapses of me washing my car before. So we have that. And then we start seeing this arm. This right here. This is a very big system. And the central, let me see if I can actually pull up WPC. Come on, hit the right buttons. So here, this is actually, I saw this last weekend when I was working at the news station. From the Weather Prediction Center. This is a new look to the surface analysis. Yeah, it's interactive, it looks like. Interesting. All right, an interactive surface analysis. So we got a thunderstorm area. Rain, snow. This is really crazy here. So we have severe thunderstorms and snow right next to the same spot. Right now this looks like it's going over Nebraska, but at least it extends a little bit into Iowa there too. This is really incredible. And let me see if it gives any information. As it's on this low pressure system, you kind of think of this as just one, even though it shows two systems there. It's on track right now to be the lowest central pressure, the barometric pressure, the lowest of any low pressure system ever in history with April. And you can see its tentacles extend quite a ways. It's not actually showing me that. Let me see if I go back. Don't think it will show me that. Will it show me the original? Oh, that's overview. There we go. That's what I was looking for. All right, so this 983. Yeah, 983 it looks like is the low, is the barometric pressure in millibars or hectopascals right now for that. And the other one is 987. So I don't think that is the lowest in history, but it's certainly up there. And if it drops a little bit more, it will be the lowest pressure in history. In April, specifically. Let's see if anybody else is watching now. All right. So who do we have here? All right, so that's the surface analysis. I want to keep this kind of in order. Ooh, I'm showing the black hole. Don't want to do that just yet. Don't want to spoil the surprise. Okay, back here. So this system, it's a slow mover. And this high is not really going out anywhere. 10, 12 millibar high pressure there. So that's going to be moving out. And if we take a look at the satellite here, let me see if I can put this in motion. You can see it's spinning in spot, but in terms of moving west to east, it's not really moving far. And let me switch this to, where is it? Shortwave. That's it. Yeah, there we go. It's not really moving much with this. And you can see our high pressure is kind of squeezed in between this moisture coming out of the Caribbean and this low pressure system over the central part of the country. But yeah, it's not a fast mover, but it's really dynamic. Let me see if I get a closer look in. Let's try here. That looks like some sort of frontal boundary. Fascinating nonetheless. We get back to continental. Okay. There we go. Yeah, quite interesting there. I just want to take a look. Anything else here? Let's try this nighttime microphysics. It's interesting just to see this, the nighttime. All the orange, or the pink, I guess you could say, that is daylight. And then as soon as it turns this yellowish color, that's nighttime. This would probably be better to see if it was all dark. And let me change the zone to here. And we'll go back to, let's do the visible, just to see a little bit until it gets dark there. But yeah, pretty nice skies. And even when you go to the infrared, you see there's really nothing. Maybe a little bits of clouds coming into South Jersey at the moment, but nothing really too much. Now let's take a look at some of these forecast models from the good old Tropical Tidbits. So we're going to watch on the continental US here. That's slow mover. And here's the time. So this is the GFS. It's showing, it looks like 2 a.m. on Saturday. Not strong, but just showers, light rain throughout the area. By 8 a.m., that next frame, mostly out of the picture. And then by 2 p.m. Saturday, it's pretty much good. So that is the GFS. Now I'm going to bring up the icon model. And we're going to look through the same thing here. Oh, that's the 120 hour. I want the 12Z, which is the 180 hour. Wait for the rest of the frames to load. All right, let's scrub through this. So this is actually a little bit faster. So 3Z Saturday, that's 11 p.m. Friday. That's showing, that's where the rain is really coming from. Hello, M. And if you don't understand, feel free to ask. We could talk all about this. This particular forecast model, the icon model, this is the Germans, a German forecast model. And this one is showing, so this time 0Z Saturday is actually 8 p.m. Friday, 11 p.m. Then we go to 2 a.m. and it's pretty much out of the picture by that point. Just still a little, especially in the Long Island area going into Massachusetts and some areas, even in Connecticut still just a little bit there. For anybody else watching, I see I have a couple other people watching as well. It's one of my friends. She's watching for the first time. So I'm on the icon model. The next one I want to take a look at in mesoscale, we're going to go to the 12-kilometer NAM. And here I'm just going to rewind the radar a little bit. Let's take a look. Once it loads, waiting on those frames to come in. Alright, so now we're in the NAM. Let's watch the NAM. Actually, this is, I think, even slower. But what was the central pressure here? It's still held at 983 millibars. I don't think that is historic low, but it's very close to being historic low, being the lowest central pressure of any April storm ever. Alright, this is very thin, very roped out, it looks like. So here, that maybe depends on the convection level. I don't think there's a lot of CAPE available, or CAPE in there. But that may be just some lines of showers, not really thunderstorms at that point. And this is right around 6Z, so that's 2 a.m. on Saturday. A little bit more intense. And this then becomes slower. So overall, the NAM was slower with this whole system. The next thing I'm going to take a look at is going into the northeast view. I'm going to switch regions. Where is it? Northeast. I'm going to take a look in here. So about the same timing between the GFS and the NAM. Let me switch the NAM over. Wait for those frames to load. So yeah, it's about the same time. So we got 6Z. That's the line on the NAM. This is the GFS. It's just a little bit less intense on the GFS itself. And if we go to the icon, I'm going to switch the region. This one was a little bit faster. So instead of 6Z, which is 2 a.m., this is 3Z, which is 11 p.m. Friday. So still, it looks like the overnight hours of Friday could be a little bit soggy there. That's fairly certain at the moment. I also want to switch. I think, does this one do CAPE? This does not do CAPE. Does the NAM do CAPE? And for those that don't know, I need thermodynamics. 850, where is it? Wind, contour shaded, nope, that one doesn't have it. Only the GFS, I think, has that. Mean surface level CAPE. CAPE stands for convective available potential energy. It's essentially the potential energy, moving energy, that's available for convection, and convection creates thunderstorms. So we do see some convection there, and that's that 2 a.m. Saturday, but this is mostly South Jersey. Doesn't really come into the area, so I don't think, especially at night, nighttime in April and spring is not really going to have anything much at all. And that pretty much just peters out, and that's going into Sunday. We'll take a look at that a little bit later. So that is, come on, go back a little bit. There we go. So nothing really in terms of Friday night to Saturday for the Cape. Now if we go here, that's Friday night to Saturday. Saturday itself doesn't look like a bad day. Maybe in the morning a little soggy. And if you're in Long Island going up through, say, Boston, yeah, maybe still some showers. Not the clearest of days, but still not a bad day. And we have what's called warm air advection here. If we take a look at the isobars, which are the black lines, and these thickness lines, which are the dashed lines, and the red there, when they intersect like that, that means there's warm air coming in. The 540 line that we're all familiar with, way up into Canada, which is usually associated with the freezing temperature line. So that's not anywhere near us now. We're on the up and up with the temperatures. So let's go into Sunday. So here, ooh, that is Monday morning. Not low, 996 millibars, but that is a lot of precipitation. And that, I think, is what the GFS was hinting at with the convection. So here, we try and match the contours. And that's kind of right around 600 to 800 joules per kilogram of Cape, which is moderate. In the Northeast, and just for the scale here, I've never seen above 2,000, I don't think. Once you get into the Midwest, that's where you get these really high ones. That's what creates tornadoes. In the Northeast, you can still have tornadoes, but you don't need the higher capes. Usually, severe is right around 1,800 to 2,000 joules per kilogram, which is basically an energy density. And down here, this is kind of where we're seeing the Cape, so maybe some rumbles of thunder for Monday morning. That's really about all I would think with this. Let me just switch this back to, not the region. Let me switch this back to mean surface level pressure. And again, the GFS is just usually like this. It's more widespread out. To get a line of thunderstorms, it needs to be a bit tighter instead of this very wide area. Just pretty much the entire Northeast is getting rain. And the NAM, I don't think went out that far. Yep, the NAM did not go out that far. Now the other forecast models that I have access to, because of the television station, I cannot show anymore just because of the whole copyright stuff with YouTube. Don't want to get any strikes against the channel. Never had one, never plan to. So overall, looks like going into the first part of your next week, this could be some pretty intense rain. A little bit beyond that, this here, these bars, the lines, the isobars, they get close together, and when that happens, it's called an increased pressure gradient, which is windy. So Tuesday is going to be windy. That's the, let's take a peek at the icon model as well. Yeah, so on the back side of the low pressure system, which is usual, we have pretty windy conditions. Now I did mention here, that 540 line. That's kind of thought of as the freezing line. However, not in this particular case. Once you get into mid to late spring and early fall to maybe mid-fall, that 540 line does not line up all the time with the freezing line. Just for instance, we're going to do 2 meter temperatures. So at that same time, especially, well, more up in northern New York here. But if we look at, say, southern New York, the lower Hudson Valley, Jersey, in the 30s, so it's not below freezing, as we would assume with this. That would assume that the freezing line's right there. It's close, but it's not exactly in line with that 540 line. All right, NAM didn't go out that far. So Tuesday's going to be windy, and then it looks like we have a bit more rain coming through on Wednesday. Let's see what the icon says as well. Now this is where we start seeing big differences. All right, so I'm going to go to 18Z Wednesday. That's there. 18Z Wednesday. They are completely different. That's the challenging part with the weather forecasting, because it's more of an art form. I'm taking a little bit of both. And usually the end of a 7-day forecast, no matter who the meteorologist is, that 7th day is probably going to change. Those area or those stations that you do see 14-day weather forecasts don't really go by that. The 14th day especially. Anything beyond 7 days is going to change. So don't plan things based on anything longer than a 7-day. At least for right now. Hopefully with the more advances in technology, we can be a bit more certain forecasting out to, say, 14 days. But then really anything beyond 15 days, that starts the transition from meteorology to climatology. Okay, so that's with the weather. Now, we are going to move on to the black hole. Right on NASA. Let's see what this says. Black hole image makes history. It's the first ever picture of a black hole. And a black hole and its shadow. We're seeing the shadow, essentially, because we can't see a black hole itself. Historic feat by an international network. So this had actually been theorized a long time ago with Albert Einstein. What we needed to see something like this was a telescope the size of the entire Earth. That is not going to happen anytime soon, that we're going to make a telescope the size of the Earth. But we did something very close. So what happened was there was a network of telescopes throughout the world, positioned or different positions throughout the globe, and that in a sense worked in unison to create this Earth-sized telescope. And the Earth-sized telescope was able to get this, and it looks blurry here because it is so small. Now on an image, if you actually print this out on, say, like a 4x6 or just a regular photo, if you just print this out, this piece of the photo is 0.00001 inches. That's how small of a dot this is if you were to print out the photo. And then when we scroll down here, this is still blurry just because this is a little bit bigger. This is, I think this is a galaxy, and this is the center of a galaxy. So if we take a look right in there, very close, that's what we're seeing here. So this is X-ray. X-ray is still photography. It's still light. It's just not visible light that we see. It's X-rays. So these were X-ray cameras used to capture this. Now I'm going to go all the way back to the top, and we're going to take a look at this. So that's the actual photo. This brighter part, actually, we'll just go with the whole anatomy. So I don't know if this black hole is actually spinning. However, the light around it is. This is called an accretion disk. And the accretion disk is basically because the gravitational pull is so strong with a black hole that light doesn't escape. Light orbits a black hole, just like a satellite would orbit the Earth, because the gravitational pull of Earth is enough to pull the satellite around it. With a black hole, it's so strong that it pulls light around it. Kind of just like if you would take a weight on a string and you would just spin it around the top of your head. That's orbiting you. That's what the black hole's doing with light rays. It's so strong. It takes these usually straight lines of light and it's pulling it, and its light is orbiting around the black hole. The bottom part of this image, the brighter side, this has to do with something called redshift, which is actually how astronomers can determine the distance from Earth to a particular star. The redshift here is showing at the bottom, this brighter part, that is light moving towards Earth. The top part, the darker part, is light moving away from Earth. So you have light moving or spinning in different directions. And you usually don't think of light spinning because light goes in straight lines. That's where we see this as an actual black hole. So this is the image. Now, for anybody that has seen the movie Interstellar with Matthew McConaughey, I think it was 2014. I'll have that image here. I'm going to bring up from the movie. This is the interstellar black hole named Gargantuan. And it's kind of showing something similar. This also was just based on calculations at that time. So the accretion disk is out here on the outside. And from my understanding, you have, this is considered a stable orbit around the black hole. And then you have an unstable orbit, which is this thin line right here. This thin line. So you have light, a blank space, and a thin strip of light. So this strip of light here, before that black space, that's considered an unstable orbit. And that has to deal with light, again, being bent. So my fist here is the black hole. I have, say, a light source behind the camera here shining on me. I have the light coming out of here. If it just passes over the black hole, it's enough so that on the back side of it, let me do that. Okay, so with this, my fist is the black hole. We have a light source coming in. And remember, holes we think of as a hole. But in 3D space, a 3D hole is a sphere. Because if we take a ball and we shine a shadow onto a piece of paper, it becomes flat. That shadow is a hole of light, which looks like a circle. But the actual object is a 3D sphere. So my fist is the sphere, which is the black hole. We have light coming in. It's so powerful that as that straight light comes in, it goes near it, it pulls straight in. And as you get further away, some light will come in and start orbiting around the black hole. Some goes straight into it, some goes over and comes in on the other side, some goes around and comes under the bottom, and some just goes out and comes back in and starts orbiting. So the idea with this, in this particular generated image, I have this set up now, right? Yep, I do. Was we have light orbiting the black hole on the outside ring. I think that is, I forgot exactly what that was called. Oh, my tweet says it. I said it in my tweet what it was exactly called. Because there was a person from NASA. Here we go. This is called the last photon orbit. So if I go back to this image, this is where we're seeing the last photon orbit. That's what that's called right there. And in the interstellar, that's that same equivalent there. Now, the very thin strip of line here, of light here, just before all this blackness, that is the event horizon. That's the point of no return. Once you cross that, you're in the black hole. You cannot escape. Now, other studies have shown, if these are all theorized, because we can't actually send a person to a black hole to see, because it might just kill them. The black hole, and also this black hole, I think, is 280 like 80 million light years away, which means it took 80 million years for that light to reach us. Let me just double check if it says exactly where it was. Light years? It's not on this page. It's not on this page. Let me see if I can find the exact distance. Black hole distance. Let's see if it says it. Here we go. The image reveals that the black hole at the center of its Mazar 87, that's why I was getting the 80 confused, a massive galaxy in the Virgo star cluster. This black hole resides 55 million light years from Earth. So there's one fact. So with this one, this is 55 million light years, meaning if you travel at the speed of light, it will take 55 million years to get there. We cannot travel at the speed of light. We can't even travel at half the speed of light or a tenth. We vary like 0.00001% of the speed of light, I think, is all we've gotten to. Just a couple, less than 1%. So here, if it takes 55 million years at the speed of light to reach this, we would never reach it. We just never reach it. So it's far away. That's also why it's so grainy, because the further away, and this just is photography itself, doesn't matter what spectrum of light you're in, what spectra of light, because my movie I'm making, little plug for myself there, I'm still writing Spectra. I have my actors already, help my friends that are going to help film and act in the movie. Spectra's almost done, and basically I'm going to have the story written, and then I'm going to convert that story style into a script style, have that for all the actors, and then I don't know where I'm going to publish it, though. The story I'm probably just going to have on a site that it was like password protected. I'm not exactly sure how I'm going to distribute it, but that's coming out. So spectra, we have different light spectra that here we see as X-ray. It doesn't matter what light spectra you use for photography. The further you are from an object to zoom in, you got to crop in and you lose image quality. That's why it's blurry. But 55 million light years is quite a bit. That's where, maybe since now that we've confirmed black holes exist, there's a whole bunch of other things that may exist as well, such as a wormhole or a cosmic string. Cosmic strings, I'll just see if I can bring up real quick. That goes into, if anybody's a Trekkie, they actually talked about that. Cosmic string. Those are just artist renderings. Well, this sounds fancy. Cosmic strings are hypothetical one-dimensional topographical defects which may have formed during a symmetry-breaking phase transition in the early universe when the topography of the vacuum manifold associated to this symmetry breaking was not simply connected. Everyone understands that, right? But essentially it's if we think of space-time as a blanket, which is what Einstein was studying, space-time's a blanket, this could be a rip in the blanket. Just a single straight rip. Think of it that way, as a cosmic string. And the wormhole, let me see if there's the official definition of a wormhole. Wormhole is a theoretical passage through space-time that could create shortcuts for long journeys across the universe. Wormholes are predicted by a theory of general relativity, but be wary. Wormholes bring with them the dangers of sudden collapse, high radiation, and dangerous contact to exotic matter. Wow. Okay. So back here. From that last one, exotic matter could be antimatter. And if matter and antimatter touch, they annihilate each other completely. So that is something that you don't want to happen. And if you're traveling through the wormhole, so you have the tunnel, you're traveling through the tunnel, there's the chance as you're traveling through the tunnel, it just collapses. Because they're unstable. They need a lot of energy, theoretically, to keep a wormhole open. Maybe they exist. Now that we have confirmed that a black hole exists, maybe a wormhole exists, and not as a tunnel that we can think of, like a tube, but maybe as a sphere, which also the movie Interstellar showed. This wormhole did pop up in our solar system, and it was basically a sphere that they circled and then went into with the spaceship. Okay, now I'm going to put on the VR headset. I got that all set up and ready to go. And we're going to dive into the solar system. I'm going to create a black hole in our solar system. I don't think I could do this effect with all the light rays orbiting it. But we'll see. All right. So Universe Sandbox, this is called. And as I rearrange the microphone, I'm going to mute it so I don't break anybody's ears if you have headphones in. But let me pop this open. Okay, ooh, there we go. Okay, those are good. It's a little bit tricky to see through here, but I'm going to mute and readjust the microphone so you can hear me a little better. Okay, there we go. I think that should be good. So now I got these. I am going to load up Universe Sandbox. Let's see, it didn't pop up here yet. There it goes. Okay. There it is. Universe Sandbox. Now you can see what I see there. Alright, so this, I don't think I see the sun. But we have the earth. Now, I've talked about this before when I've done this. In terms of the grand scale, let me move this a little bit back. Okay, so in terms of the grand scale, look how far away the Earth is from the moon. That is further than all of the models actually say. And this, just to show an example of what this universe sandbox can do. This is what I'm going to do. I can take this, I got the moon, and I'm going to try and put the moon in an orbit closer around the Earth. So let's see if I get this a little bit wider. Ooh, nope, that was too fast. Still too fast. I gotta get my skills if I'm going to attempt this with a black hole. Count. Ooh. Oh. I just destroyed part of the Earth. Let's see. We're going to create another moon. Okay. Actually, I think I did that fairly well. So we have a closer orbit now. It's more of an elliptical shape, which is actually how the Earth orbits around the sun in an ellipse. So we could see our one point there, and our second point is probably right over here, and that's the 2 points of the ellipse. This is probably what everybody's used to seeing in terms of how far the moon and the Earth are. The other kind of neat thing is when I made this trail is showing the Earth actually moving. And then what I can actually do is make some more. So this is where I can just go crazy here. And also some of these moons are getting really big. And now we have a molten Earth. Okay. Enough fun. Well, at least for this part. Now, what I'm going to do is open solar system. Okay, now this is the whole solar system. When we had the coronal mass ejection, I did this too. So it's going to get bright. I'm going to teleport to the sun. Oop, no. There we go. Okay. No, I can't do that. I gotta face you guys. I'm trying to reload. Oh, wait, I can move. Fly. Okay. There's the sun. Now we're in view. Let me see, can I move? Not that way. I want to move that way. It's a little bit further away. Okay, so now there's the sun. Everything's orbiting around it. I am going to... Can I do that? No. Wait, how do I do that? First, I want to slow this down to about 1 second per second. 4 seconds per second. Totally fine. So now this is essentially moving in real time. So the sun. How did I... Oh, also, let me see if I can move. As a little comparison here, this is kind of freaky, just in VR being this close. Okay, so we got our sun right there. I am going to open the Earth. So there's Earth. Look at the size of planet Earth compared to the sun. Ooh, look at that. That is freaky. And you can see even it's being pulled a little bit. Now I'm going to try and get really close. It's not moving as fast as I thought. Try and manipulate time. We're going to speed that up a little bit. There they go. We changed our sun. Just because the mass of the Earth is essentially being added to the sun. Now, I'm still on fly. Now we're going to make the black hole. There's a couple of ways I could do this, but essentially what you want to do is increase mass. See, there's a black hole creator here. I don't want to create. I want to see if I could change. No, that's just putting more Earths out. However, oh, I know what I could do. Dispense. So this, see, is dispensing hydrogen. However, I'm going to do a couple things here with the dispensary. Velocity, I'm going to up that just a little bit. This shouldn't do much. Let me see. See, it doesn't, just because it's still actual mass of hydrogen, it's not doing much. But I'm going to take this mass and up it. 12 Earths. Let's see if it does anything. This always freaks me out when something changes, but it's not doing anything yet. But you can see it's growing. Essentially, the mass of the sun is increasing. Now we're going to go even more. This is mass of 12 Earths. We're going to do 1 sun, or about a sun, 2.5 suns. This, I think, is going to cause an issue. So let's do this. Let's see what happens. See, it's starting to change. See, the gravity's changing now because all this is going faster. Where's the rest? Oh, I think I destroyed the rest of the solar system. Let's keep shooting. So we're basically increasing the mass of the sun. Gonna go even more. 228 suns. All right, this. I want to go a little bit further away. So 228 suns in each dot. This may cause... See, it's heating up. Just heating up there. Okay. Apparently a supernova didn't happen, which I thought it was, but there is your black hole. So I don't know what the VR thing's seeing. But this is kind of the theory of what the black hole is. In the very center, that's the shadow of the black hole. And the more I actually shoot into it, see, it's growing, it's feeding. And this is actually a scientific term. It's feeding. Oh, what's that orange thing? What is that? Oh, that's stuff from far away coming in. That just fed into there. That was interesting. But see how it's almost like a split view? So I'm seeing the accretion disk here. That's the light disk essentially around it. But as I keep moving, it doesn't really change anything. And now we're just seeing black. See, it's not going exactly around. What I'm trying to get is orbit. But remember, this is really high gravity. I don't know what that stuff is. Let me see if I head a little bit away. Oh, there it goes. It's feeding more. And this is essentially how supermassive black holes become. They just keep feeding. Whee. What was that? Don't know what that was. But as I keep feeding the black hole, probably stuff elsewhere may come in. But this is the whole science part here of what they discovered today. So that, I don't know if you can see that view. There we go. Kind of. That little dot in the middle. That's the accretion disk. They made it too big to handle. But a hole in space is a sphere. Don't want to get too close to it just yet. I still have no idea what those orange things are. We kind of see the accretion disk there. Oh, something else just came in. That didn't work. See, look how That's just crazy. I'm shooting stuff outward, and it's just being sucked back in. Now, what I'm going to do is fly inward here. It's not actually going to do anything when I fly in. It's just going to look really weird. So we could see the event horizon. There it is. I'm nearing it. And I passed through it. Where'd it go? Come on, go back in. Go out the cross. There. This is inside the black hole. So this, I don't know if it's actually true. No one knows what the inside of the black hole looks like. But that, I can kind of still see the black hole not exactly in the singularity. There we go. This is freaky looking. This almost looks like what Interstellar was showing. And to figure out that we, or like just contemplate that we actually saw one of these black holes. Let me see if I get back out. There's the event horizon. Now you may also be thinking, what about two black holes? All right, so it's going away. So let me create another one. We're going to switch this to the Create tool. Create, not on Earth, a black hole. So there's another black hole. Oh, it's doing it. This is doing it. So this, you can see what looks like a loop around. The interesting part with these black holes, because they're bending light, I could see something that's on the backside because the light's being bent around it. So I don't think, yeah, the controller doesn't do, it's not actually in the physics. But I just want to see. So there's a big black hole. Here's a little black hole. Look at that. Will it come through? There we go. So the only thing that can actually, at this giant black hole that orbit another one, a black hole can orbit a black hole. We got those two coming back together. The more black holes I create, the faster they actually start orbiting. So if I shoot one out this way, look at that, see? Now this is all virtual, but however, I feel really freaked out right now. See how they interacted? Now I'm just shooting more black holes in here. So it's making essentially this one grow. But all these other ones are orbiting. Is it moving? It's moving. I'll probably have to reset this soon. Alright, so this is a lot of physics that's happening right now. I'm just glad the computer's keeping up. Oh, look at that one. See if we can get there before. I don't know what this one's doing. That just looks freaky. Oh. It's gone. That looks freaky too. So there's where we could kind of get the kind of the interstellar thing where we have these loops happening. Now, should we actually be able to move this? Let me see. Move. Alright, Sun Supernova Remnant. Look at the mass of that. So that is 1, 2. Ooh, why'd you move? 1,354,249 suns. And that just keeps adding. See, look at that. So one of these, does it say what the mass is? 10,000 mass suns. So each of these is a 10,000, which you can see there. All right, let's get from move. Wow, it's getting harder to move now because this is just so big. But there's your black hole. I'm holding a black hole in my hand. That's freaky. I see a comment. Hold on. My glasses get stuck inside there. Hello, Anthony. Thank you for joining. All right, let me dive back in. So what I'm actually going to do is reset this. Because this black hole got really big really quick. Okay. Reset. We're going to open. Is there anything in here? Supernova close up. Let's go into this. Okay. Let's go into move or fly. There we go. We're going to fly around this. So there's a supernova. So it's essentially this sun that's collapsing. Why is it not showing anything else? Let's go into create. What's the time on this too? A second per second. So this is real. This would be real time. I'm not going to create a moon. I want to create a black hole. So remember before how big that was? Look how tiny this is. Look at that. It's not feeding on anything just yet, that black hole. But it's moving. Just want to see what happens when that black hole starts feeding. Because right now, it's just dormant. It's really interesting to see really close up. There's your accretion disk. Oh, not feeding yet. Let me try and put one in here. Nope. But instead of there. So I have a couple of black holes. That one looks bigger. It's feeding. There's not really much in there. That one. Am I still on fly? I am. There we go now, outside. Oh, as I look, that's interesting. So it's still in here. Oh, there's the sun. Let's see what happens here. It just absorbed it? That's interesting. This is so freaky. Oh, there's a bigger one. It's actually not. Is it? I don't think it's feeding on anything. Oh, it's just going right through it. Okay, that's a bad example. So, we are going to go back to the solar system. Actually, no, we're going to go back to Earth. There's Earth. Now I'm going to create another black hole. So that's Moon. We don't want that. Let me see. Black hole 1. Is it in there? Whoa. What? That was freaky. Oh, it's tiny. Oh, and the two black holes are interacting. Okay. Let's reset that. Do we have any? It would be neat if they actually added in anything. Earth and Moon slow-mo. Human-sized objects. Oh. Galaxy collision. I'll go to there next. I'm going to just go back to here. And in this, so we're back into the Earth. So we're going to create black hole, but a little bit bigger. All right. So this is a black hole that's 100 mass. So still, it looks tiny compared to the Earth. If an actual black hole was that close, it would be bad. So I'm going to set it free over here. Look at that. That's how massive it is. And now we have these light streams. This, I actually don't know what the phenomenon is. Oh, I think I just figured this out. These black holes are traveling faster than the speed of light. So this is almost like a sonic boom. It's creating a light sonic boom. All right, let's reset that. We're going to go to solar system now. Okay. So that's the sun. We're here out in the outer part of the solar system. I'm going to create black hole 100. Still looks tiny. 100 mass. There it goes. All right, we're starting to see some things. Look at that. We get to move. It's orbiting. Fly. There's things orbiting the black hole here. Just because it's so tiny compared to everything else. It's a fast mover, too. See how tiny it is? Whoa, what? I think I just killed everybody. Oh, I think now the computer's struggling. See it stuttering? I don't see the VR stuttering, which is good. Oh, these light beams too, I think were also captured. I just want to see also black hole. That was 100. We're going to go 10,000. Whoa. Something major's happening there. So that's a 10,000 sun mass black hole. Let's see, will it disturb anything? Okay, everything's freaking out now. You reset this to solar system. Okay, now the solar system's reset again. I'm going to go back one more time to create black hole 10,000 mass. So that's 10,000 mass of the sun. I'm just going to let this go. And that just disrupted everything. Oh, there's the sun. See how disruptive these things can be? I mean, it kind of looks like a beautiful art. The one last thing I want to try, it's just so tiny. We're gonna reset the solar system, and then we'll show you the two galaxies colliding. Solar system. Okay, I'm gonna teleport right to the sun. So there's the sun. Now I'm gonna open up a black hole. 10,000 sun mass. Okay, it's a little bit bigger. I don't want that big. We're gonna do 100. I don't even see it. Alright, we'll stick with this. Black hole 10. Whoa, that is huge. That would just swallow the sun. I don't want to do that. We're gonna have just little experiments. It's black hole 1. Wow, that's huge. $10,000. We'll stick with that. Explosion. That's it. Also, if we looked at it this way, the computer program's a little bit stuttering just because it's a lot of calculations to do. But see how everything's speeding up as it gets close there? This, where are you guys? This is how before calculations were done. By calculating the movement of the stars or objects around this empty space, around this thing, which is the black hole. And fire. There they go. Fire. Yeah, if I could actually shoot black holes out of a gun, everybody would die. Now this would actually break, I guess, laws of physics. Yeah, I guess that is breaking the speed of light. So, in terms of speed of light, now we'll end the program. Let me switch back here, and we're going to end this. Okay. In terms of the speed of light, the calculations have everything go right up to like 99.999 repeating for the speed of light. Can't get exactly the speed of light. However, if you take those same calculations already faster than the speed of light, that would work. I'm going to reset the microphone real quick. Well, I just realized I'm an idiot. I just realized for the last bit of the stream, I wasn't showing the background. Oh well. I'm going to call it here. So, exciting day in the scientific community. Hope you had fun. We played with some black holes. We talked about the weather forecast for the next week. So if you want to check out some more, hit that little subscribe button below, a little bell icon right next to that, so you get notified whenever I upload a video or I go live. Now I'm going to try and get my Full Throttle Thursday video out for tomorrow, and that's going to be on the oil change and some things you should do for spring maintenance that we're now out of all of the winter stuff, at least in the Northeast. Different for the Midwest with the blizzard going on right now. But I'm going to have that coming out tomorrow. All right. Hope you enjoyed. This is meteorologist Andrew Pinero. I will see you all in the next video.